Sandhya Devi.
Sir, could you please share the screen in English?
Sure, sir. Already just and before that I explained. I was telling in English. Okay, no problem. Question is also
Okay.
repeated here in English. Okay. Now because recently just I posted in Telugu medium student for Telugu medium students purpose. That's why that is the major part. Okay. Now these problems are also in your textbook. No problem now. Hello, Janaki madam. Hello. Okay, just you have to see here. Anyhow, good morning to everybody here once again. Hello. Okay, anyhow, once very good morning today. Onwards is also yesterday we have to explain some other concepts. Now that is also major part of group examples are also explained here, and simple properties of groups are also well defined here. And according to you have to explain the some other problems. Now yesterday in the last hour we have to explain the some problem A star B equals to AB by 2 to form a finite abelian group is there. Okay, see this one example. Okay, this example. What is that? Here, the set of all positive rational numbers under star be the one of the binary operation. Okay, here this is the meaning of. Just please note down this example. Already this problem is in your textbook. Okay, just you have to see and refer. Okay, yesterday last session we have to explain especially this problem. The set of all positive rational numbers under star be the one of the binary operation. Here A star B equals to AB by 2 to form an abelian group. Okay, what is the rational number form? Here the rational number form is Q equals to B by Q form is there. Now given the relation is also defined here AB by 2. Okay, now this problem is also explained in the last session. Okay, some once I have to repeat here because there are 2 minutes yet 10:30. Okay, very few minutes, 2 or 3 minutes to 10:30 is there. Some other students are also joined, so that's why just I have to repeat this problem. Okay, now this is the set of all positive rational numbers. Q plus means set of all positive rational numbers under star be the one of the binary operation. Now here especially here A star B equals to AB by 2 is there. A star B equals to AB by 2. Now to form an abelian group. Now here the relation is AB by 2. So first of all, you have to mention the given the solution. First you have to write the given the data. The given the set be the set of all positive rational numbers under the star being the one of the binary operation. Okay. Now that operation is defined here. A comma B belongs to G. AB belongs G. First of all, note down here. Okay. Now, first of all, to form your group means G1, G2, G3, G4. Okay. Now, there is no difference between Telugu medium and English medium, especially in mathematics. Okay. Now, enter the data must be explained in the English medium. There is no doubt. Now, here the notes is in the Telugu medium. There is no some other terms are also just have to make the Telugu medium for your for the Telugu medium students' purpose. Okay. No problem. Here, first of all, just you have to observe the given the relation. Here A comma B belongs to G and AB belongs G. Okay. Now here the rational number means now that must be dividing with 2. That is AB by 2 also belongs to G. But just you have to observe the given the data. AB by 2 means A star B belongs capital G. Therefore G under star must be closed is there. Here the closure condition must be verified. Second one G2. Suppose G2, we are taking the 3 elements, A, B, C, or any 3 elements given in the set, capital G. Now, what is the associative part? A star of B star C equal to A star of B star C means BC by 2. Suppose BC by 2 is, say, X is there. That is A star X. Okay. Now, here, what by definition, A star x means ax by 2. That is replacing x value, replacing by the x value by bc by 2. That is a of bc by 2 by 2 is there. Now that is ab of c by 4. Okay. Now that can also be written as ab by 2 into c by 2. Now we know that ab by 2 is some value is y is there. Y into c by 2 means y star c. Y means a star b, because y means ab by 2 by the definition replacing y by a star b. Now that is the easy conversion, our convenience purpose. Okay. Now this is a star b of star c. Now finally we are getting the value associative property a star of b star c equal to a star b of star c is there. Okay. That's enough. Now associative law holds good. Now G3, this is the existence of identity. What is the meaning of identity? When E be its identity element given in this part, E belongs to G. When what is the condition of existence of identity? A star E equal to E star A equal to A. This is the existence of identity in with respect to the composition is star. That's why A star E means AE by 2, and at the same time AE by 2 means AE means EA by 2. EA by 2 means E star A by definition. Finally, we are getting the value A star E equal to E star A equal to A. Here E be its identity with respect to the star be the composition. Okay. Now this is the here just you have to observe what is that A star E equal to A. Suppose A star E means by definition AE by 2 equal to A. Okay. We are taking at right side of the identity A star E equal to A, and A star E means definition AE by 2. Now that is an equivalent to by identity property. The value is an equivalent to A is there. Suppose the left cancellation law. Now here A is cancelled, and when the cross multiplication E equals to 2 into 1, that is E equals to 2. Therefore, 2 by its star be its identity. Here the identity value is equal to 2 with respect to the multiplication, with respect to the star be the composition. Okay, that is the existence of identity. This is the right identity and this is the left identity. Replacing this one, A star 2 equal to 2 star A equal to A is there. Okay, that's it. Now G4, this is the existence of inverse. In your textbook, that is also in your textbook, just you have to observe this one continually. Just you have only express some concept is there. Okay. Now what is that concept? Directly, just you have to read some short answer is given, but should not mentioned here. Just you have to mention. Just we must mention this type of answer. Okay. G1, G2, G3, G4 is there. Now G4 is existence of inverse. When B be any non-zero element, that non-zero element means inverse exists. What is the existence of inverse? A star B equal to B star A equal to E is there. Okay, that's enough. Now B its non-zero element means inverse exists. Therefore, A star B equal to E is there. What is the identity? Inverse completely depends upon the identity part. Therefore, A star B equal to 2 is there. By definition, A star B means AB by 2 equals to 2 is there. Okay. Therefore, finally, B equals to 4 by A. This is the inverse of A. Okay. Now, finally, G under. Please stay on the line. Okay. This is just one class. Hello. Okay. Now finally, G under star means G given the set of the elements is positive rational numbers. That's why positive rational numbers and with respect to the star multiplication. Now that is the form of a group is there. When G1, G2, G3, G4 are satisfied, that is called a group. Now again, just to have, when the group must be satisfied with the commutative property, now that is an abelian group. When A comma B belongs to G, this is the commutative. A star B equal to B star A. Suppose the multiplication as the composition, AB equal to BA. Suppose addition be the composition, A plus B equal to B plus A. That is the commutative property. Now just you have to observe by the given the data, A star B equals to AB by 2. Now, therefore, AB means AB is an equivalent to BA. BA by 2 means just you have to observe replacing A by B, B by A. Therefore, B star A is given. Now, finally, we are getting the result is A star B equal to B star A. Therefore, the given set mentioned the elements is positive rational numbers and star B the composition is an abelian group. Okay, that's enough. Yesterday already I have told here. In the same manner, suppose A star B equals to AB by 3. Here, therefore, set of all elements are positive rational numbers. Okay. Now, the question is given star be the binary operation. The given set be the elements are positive rational numbers are defined with respect to the star be the composition is defined by A star B equal to AB by 3 form an abelian group. Okay, that is the question. Now the above example is A star B equal to AB by 2. But here A star B equal to AB by 3. Okay. Now in the same manner, first of all, so you have to mention the given data just like that here. Just see here. What is the given the data? A star B equals to AB by 3. Now here A comma B belongs to G. The given set of all the elements are positive rational numbers. To prove that Q plus under star form an abelian group. First of all, so we will show that the Q plus under star form a group. That is G1. Closer condition is A comma B belongs to G. Therefore, AB belongs to G. Now, according to this one, AB by 3 is also AB belongs to G and AB by 3 belongs to G. Therefore, A star B belongs to G. Now, now Q plus under star is closed. Okay. Second one. What is that? Associativity. A star B of star C equal to A star of B star C. A star B means AB by 3 of star C. Okay. Therefore, that is same manner. AB by 3 is X. X star C equal to XC by 3. XC by 9. Therefore, X of C by 3. X means A star B of star C. That is A star of B star C. We are getting the result is A star of B star C equal to A star B of star C. Now, just you have to observe here the next G3 part. What is the G3 condition? G3 is existence of identity. What is that? Existence of identity is there. Here E belongs to G. Okay. Suppose E be its identity element. A star E equal to AE by 3. EA by 3 equal to E star A. Suppose we are taking A star E equal to A. Okay. Now, this is the right identity with respect to the star composition. AE by 3 equal to A. Therefore, AA left cancel by left cancellation law, we are getting the result is E equal to 3 is there. Because A both sides, A can also be written as A into 1. Left cancellation law is also applied. Therefore, finally, when the cross multiplication E equals to 3 is there, when A star B equal to AB by 3, identity element is 3. In the same manner, existence of inverse. Okay. Now, just you have to verify the identity property. A star E equal to E star A equal to A. We are taking the value is A star 3. Identity element is 3. A star 3 equal to A. Okay. A star 3 means by definition 3A by 3 equal to, we are getting the value is A is there. Now, that is the verification of existence of identity. When the right identity and the left identity must be equal, when A star B equal to AB by 3 is the given part, here the identity element is 3 is there. In the same manner, existence of inverse is there. What is the existence of inverse? A star B equal to B star A equal to identity. Inverse is always completely depends upon the identity part. Here the identity element is 3. Therefore, A star B equal to 3 is there. A star B means AB by 3 equal to 3. Therefore, AB equal to 9. B equal to 9 by A. Now, this is the inverse of A. B is the inverse of A. Now, that value is, B value is 9 by A is the inverse of A by the defined part. In the same manner, now that is the part Q plus under star to form a group. When the commutative property is also satisfied, that is A star B equal to B star A. Suppose A star B equal to AB by 3, at the same time BA by 3. BA by 3 means by defined part B star A. So, when the commutative property is also verified, finally, that's why Q plus under star to form a finite abelian group. To form an abelian group. That's it. Here, A star B equal to AB by 4. In the same manner, identity element is 4 and B equal to 16 by A. Now, same, that is the given the parties. First of all, how to prove this one? First of all, write the given the data and to prove that Q plus under star to form an abelian group. To define the part A star B equal to AB by 4. Therefore, A comma B belongs to G, AB belongs G. Therefore, AB by 4 belongs G. This is the rational part. Therefore, rational part is also verified here. Q plus under star is closed. Now, associativity, identity element is 4 when this is AB by 4, that is A star B. Now, inverse is, what is the inverse element? B. From the condition G4 is A star B equal to B star A equal to identity. Here, the identity element is 4. Therefore, when we are getting the value A star B equal to 4, AB by 4 equal to 4, when the cross multiplication AB equal to 16 and B equal to 16 by A. Now, this is the inverse of given the element is A. B is the inverse of A is there. From the G4 condition, A star B equal to B star A equal to A is there. That's enough. Now, these are all, now this type of question is given. This is also one of the fill in the blank or multiple choice. Find the, which is the identity element to define the part A star B equal to AB by 4. Now, the identity element is 4. What is the inverse of A star B equal to AB by 4? That is 16 by A. Okay. Now, just in the same manner, just you have to observe, some competitive examinations are also, now this is the algebraic part. Now, this question is also given in the further after the graduation. We will explain. We will attempt some other concepts of competitive examinations. Okay, in competitive examinations also this type of question is also given. There are so many times in competitive examinations is given, which is the identity element A star B equal to AB by alpha. Here the identity element is alpha. What is the inverse? Here B equal to alpha square by A. Suppose alpha equal to 2 square means 4 by A. That is the verification. Okay, here AB by 3 means identity element is 3. B equal to 3 square 9 by A. Okay, now this type of question is given. Next one, students listen carefully. Now finally, star be the one of the binary operation. Okay, please stay on the line. Star be the one of the binary operation. Now the given set of all elements positive rational numbers. Positive rational numbers. Please stay on the line. Positive rational numbers. Now we are the just we have to prove that now that is Q plus under star form an abelian group is there. Okay, that's enough. Another one, just you have to see here. A circle B, A star B equal to A plus B plus 2. This is also one of the defined part. How to derive this one? Here A and B are real numbers or whatever it is. Okay. Here A comma B both are being the real numbers. A comma B belongs to capital R when A star B or A circle B equals to A plus B plus 2. Okay. To form an abelian group. How to define this one? If A star B equal to A plus B plus 2. These examples are also given in the end of this unit. Okay, end of this block. There are so many problems to form an abelian group. Now this type of problem is also given. When star or circle, whatever it is. Here the binary operation is the star and or circle is also another binary operations. These are all universal operations. That's why here A star B or A circle B, whatever it is, there is no problem because that is the universal operation. Here that is A plus B plus 2. What is the identity element? Now, according to this problem, to form an abelian group is there. First of all, we should mention the what is the defined part? A star B equal to A plus B plus 2. That's enough. A star B equals to A plus B plus 2. So now according to this one, this line. Okay. Now A circle A star B equals to A plus B plus 2. Therefore, A comma B belongs G and A plus B belongs G and A plus B plus 2 is also belongs G. That is A star B or A circle B belongs G. Therefore, Q plus under circle or star, whatever it is. Now that it must be closure condition is verified. Second one, a circle of B circle C or A star of B star C equal to A star B of star C. From the definition, G2 is there. A circle of B circle C or A circle B of circle C. A circle B means A plus B plus 2 under star C. Okay, A plus B plus 2 means X. X star C means X plus C plus 2. Again, X value is substituting. X value is A plus B plus 2 plus C plus 2. Okay, that is A plus 2 of B plus C plus 2. B plus C plus 2 means that is B circle C or B star C. Therefore, finally, A plus of B star C plus 2 means A star of B star C. That is associative law holds good. Now, third one, G3 is there, particularly here. What is the G3? Which is the identity element from defined part. Just you have to observe, even the relation is A plus B plus 2, that is the A star B. Suppose A star E equal to A star E means by G3 property, A star E equal to E star A equal to A is there. A star E means A plus E plus 2 equal to A is there. Therefore, E plus 2 equal to, what is that? A minus A, that is cancelled. Okay, both sides A cancelled. Finally, E equal to minus 2. Okay, E value is minus 2. Now here the identity element from the defined part, which is the identity element, that is the minus 2. Okay, therefore A star E equal to E star A equal to A. Now that condition is also verified, that is the existence of identity. Now from the given the defined part, identity element is minus 2. That's it. G4. What is the G4? Existence of inverse is there. What is the existence of inverse? A star B equal to B star A equal to E for all A comma B belongs G. Now defined part is, first of all you have to take an A star B equal to E is there. A star B means A plus B plus 2 equal to, what is the identity element? That is minus 2. Therefore, according to this one, B equal to plus 2 is also converting this side. Minus 2 and minus 2 is minus 4. And plus A is also this side, taking it this side. That is minus A. Finally, from the given the data, B inverse element is minus 4 minus A. That is the inverse of A from this relation. A star B equal to E. Means B is the inverse of A. Okay. There, what is the inverse value? What is an inverse value? Minus 4 minus A. Be an inverse of A element. Okay. That's it. Now here, A circle B equal to or A star B equal to whatever it is. Okay. Now in the same manner, this is the given the defined part. Suppose in sometimes A circle B equal to A plus B minus 2 is there. What is the identity element? A circle E equal to A, that is A plus E minus 2 equal to A. Therefore, E equal to 2 is there, plus 2 is there. Identity element is plus 2. When A circle B equal to A plus B minus 2, identity element is plus 2. Suppose A plus B plus 2 is there, identity element is minus 2. That's enough. Okay. Now, that is also in the same part. Now, that is here Q plus under circle or R under circle to form a group. When the commutative property is also verified, that is called a finite, that is called with that is the form of an abelian group. Here, particularly G4, existence of inverse is there. A circle B equal to E circle A equal to E. When the defined part is A plus B minus 2, therefore A circle B equal to E. Now that is A plus B minus 2 equal to 2 is there. Because here identity element is 2 from this condition. Okay. Now there are so many problems. Now here A circle B equal to A plus B plus alpha. What is the identity element? Minus alpha. Inverse is minus 2 alpha minus A. Okay. Suppose alpha equal to 2 is there. That is minus 4 minus A. Okay. Above. Okay. Suppose this is minus alpha. Identity element is alpha. B equals to 2 alpha minus A. Okay. That's it. Okay. Now these are all when the commutative property means A circle B equal to B circle A. That is A plus B plus 2 equal to B plus A plus 2. Therefore, that is B circle A part. Now these are all problems to form an abelian groups. Now observe this one. One of the important problem. This is very important problem. Now these examples are common examples now till the end of this algebraic part. Okay. Hello. Hello. Can you hear me?
Yes, sir. Yes.
Okay. Now this example is very important. Please note down this problem. Prove that, students, please note down in English medium.
Okay, sir.
Okay. Prove that the set 4 and 4th roots of unity elements. Prove that the set 4 and 4th roots of unity elements with respect to multiplication as the composition. With respect to multiplication as the composition or under multiplication, whatever it is, to form a finite abelian group. Form a finite abelian group. Okay. Now, this example and the next we will explain another problem is there. These two examples well defined till this end of algebraic concept. Algebra is nothing but only group theory, and group theory is the primary part. First of all, number theory. First of all, we must know that number theory, and according to that group theory and ring theory, and according to the ring, we have to define the field concept. Now, this is only syllabus in algebra in UC level. Okay. Now, that is the groups and groups, rings and fields. That is the main part of algebra in your syllabus. But now that algebraic concept must be elaborated up to 22nd stage in universal stage. Okay. Now, this is not an ordinary thing, because only especially we have to learn much more and more concept of algebraic structures through the algebraic structure. Okay. Now, this is the main part is group theory, and according to group theory, we have to define. We will explain the rings and the fields is there. Okay. Now, these examples are so many times repeated till the end of this syllabus. Okay. Now, prove that the set. Once I have to repeat the problem. Prove that the set 4 and 4th roots of unity elements with respect to multiplication as the composition to form an abelian group. That is the problem. Okay. First of all, you have to observe what is the 4th roots of unity elements. Very important concept is, don't just you have to see here. 4th root of unity means 4 root 1 equals to I is there. Okay. Please note down 4 root 1 or 1 power 1 by 4. That element is say imaginary of 4th roots of unity. This is the concept is. Please note down. Prove that the set of all imaginary of 4 and 4th roots of unity elements, or 4 and 4th roots of unity imaginary elements, whatever it is. Imaginary means imaginary element is denoted by, this is the complex number. So that is the representative of that element is denoted by I. I being the imaginary part. Now, what about the relation of I? I square equal to minus 1. Okay. What is the value of I? I equals to root minus 1. But the given data, imaginary of 4th roots of unity. Imaginary of 4th roots of unity means 1 power 1 by 4 equal to I. That is 4 root 1 equal to I. In the same manner, I power 4 equal to 1. I power 4 can also be written as I square into I square. That value is minus 1 into minus 1 equal to 1 is there. This is the 4th roots of imaginary of 4th roots of unity. Unity element is 1, and 4th root means 4 root 1 equal to I. And in the same manner, 1 power 1 by 4 equal to I means I power 4 equal to 1 is there. So I power 4 equal to 1. How can it be written as I power 4 equal to 1? I power 4 plus 1 converting into this side, that is I power 4 minus 1 equal to 0. Now I power 4 can also written as I power 4 minus 1 power 4. Okay. Now this is a power 4 minus b power 4. What is the formula? A square minus b square into a square plus b square equal to 0. Fourth roots of unity means I power 4 equal to 1. Now this is 1 power 1 by 4. That element is imaginary. So 1 power 1 by 4 equal to I. Now that can also be written as I power 4 equal to 1. Now this can also be written as 1 converting into this side, I power 4 minus 1 equal to 0. That is the equation of this part. Now this is the form a power 4 minus b power 4 means 1 power 4. 1 power 4 means 1. So a square minus b square into a square plus b square. A square means a element is I, b element is 1. Replacing that values, substituting the values, a square minus b square, I square minus 1 square, I square plus 1 square equal to 0. Again, a square minus b square expression, a plus b into a minus b of I square plus 1 equal to 0. So finally, we are getting the elements is capital G equal to, what is the I value? I be the complex number. Those elements are, this is minus 1, this is plus 1. Now I square plus 1 equal to 0 means I equal to, that is the plus or minus I. We are getting the values I equal to root minus 1. Root minus 1 means plus or minus root minus 1 means plus or minus I. Plus I minus I. So we are getting the elements given in the set is imaginary of fourth roots of unity elements are 1, minus 1, I, minus I. Students, it is clear. Imaginary of fourth roots of unity elements. How to express this one? This is the derivation of this part. Imaginary of fourth roots of unity elements. That is 1, minus 1. According to these equations must be equal to 0. We are getting the roots of those values. 1, this is 1, minus 1, and this is the plus or minus I values, plus I and minus I. Now that is the given the set of imaginary of fourth roots of unity elements. But here the composition is multiplication. Okay, multiplication as the composition. Now, first of all, according to those elements, now first of all, you have to express this one in examination. That is, this is also mentioned here. Now, according to this one, we are getting the elements of the given the set. That's it. Now, to prove that G under multiplication to form a finite abelian group, to form a group and abelian group, okay, or finite abelian group. Finite means what is the group of when it is the group must be a finite. Given the set, given the group of the elements is fixed. Fixed elements means when the elements is finite, that is called a finite group. Otherwise, it is an infinite group. Yesterday, I also just I have explained finite and infinite groups. Okay. Now, according to that, the number of elements is 4 given in the set. So, this is when it is the group, order of the group is mod G equal to 4. Order of group denoted by O of G equal to mod G. Mod G means cardinality of the group is there. Now, before first of all, we shall show that G under multiplication to form a finite abelian group. Finite means the number of elements is fixed elements. There are total number of elements is 4. No group of the order is 4. That's why this is the finite group. Otherwise, it is an infinite group. Okay. Now, finite abelian group means first of all to form a group. When the group means G1, G2, G3, G4 properties are satisfied. Now how to satisfy this one? Now individually you have to, we should not mention the individual properties are mentioned here. Okay. Now according to the composition table, what is the composition table? The given set of all the elements must be arranged as the columns and rows. 1, minus 1, I, minus I. This is the formation of composition table. Yesterday already I have to repeat it here. 1, minus 1, I, minus I. This is the row elements. Given the set of elements also must be arranged as the columns. 1, minus 1, I, minus I. 1 into 1, 1. Because multiplication has the composition here. 1 into 1, 1. 1 into minus 1, minus 1. 1 into I is I. 1 into minus I is minus I. And in the same manner, minus 1 into 1, minus 1. Minus 1 into minus 1 plus 1. Minus 1 into I is minus I. minus 1 into minus I. Minus into minus plus 1 into I is there. Now, in the same manner, I is also multiplying with these elements. I into 1, I into minus 1, minus I into I means I square. I square value is minus 1. Okay. Now, I into minus I, plus into minus, minus, and here my minus I into I is I square minus 1, minus of minus plus 1 is there. Okay. Minus I is also multiplying with each and every element given in the set. Minus I into 1 is minus I, minus I into minus 1 is plus I, minus I into I is minus I square means that is the plus 1. And the minus I into minus I again, minus into minus plus, I into I is I square value is minus 1. Now, already yesterday we have so many problems practiced under addition modulum, under multiplication modulum, but here we mentioned here, especially just you have to observe here. What is that? Imagine we have 4 groups of unity elements. We must be arranged given the set, and those elements must be, all the entries must be filled in the composition table. All the entries means those blocks must be filled in the group with respect to the group set of the elements. Now, the outside of the elements are not repeated given in this row. Okay, 1 minus 1 I minus I. So just you have to observe. Any outside element is there, but here there is no outside of the element. So that's why all the postulates must be satisfied. Now, just you have to observe given the set. Okay. Now, the given set of the elements, one reads here the multiplication as the composition. What is the multiplicative identity? 1 be the multiplicative identity. Now, when the identity must be there given in the set, if it is not there, that is not a row. Okay. 1 is here. Multiplication is the composition. That's why now every element must be coincide with respect to the block of the elements. Okay. Now 1 into minus 1 is there. 1 into I is there. 1 into minus I is there. Any two elements must be closed and closure axiom is verified. Now we are taking the 3 elements. Associative law holds good. Yes, A of B is equal to AB of C. G3 is already repeated. 1 into minus 1. A into 1 equal to 1 into A equal to A. Okay, that's enough. Now G4 is the inverse. Now how to find the inverse? Just you have to hear. Inverse is completely depends upon the identity part. Here 1 be the multiplicative identity. 1, we are getting the 1 is at 1. So 1 be the inverse of 1 is there. 1 power minus 1 equal to 1 is there. Because we read as minus 1 power minus 1 means the inverse of the element. Inverse of the element of 1 is 1. Inverse of the element minus 1 is, okay, just you have to minus 1. How to get the minus 1? Minus 1 into minus 1 equal to 1 is there. Very important. Okay. Minus 1 into minus 1, we are getting the value is minus 1. Okay. Minus 1 into minus 1, because minus 1 be the inverse of minus 1. Now we will get the value is 1 is here. Therefore, identity element is there. So A into B equal to E. So minus 1, which element is multiplying with 1? Which element is multiplying? We will get the result is 1. So minus 1 is into minus 1. We are getting the value is 1 is there. That's why minus 1 will be the inverse of minus 1. I value when it is the 1. I value when it is the 1. Now I is also the inverse of I is minus I. We will get the value is 1 is there. Okay, because A into B equal to E. Therefore, I is multiplying with minus I. We will get that. We have to find out the identity element. Okay, so I be the inverse of minus I. When we get the value is 1 is there. Minus I be the inverse of I is there. Now that value is 1 here. Therefore, 1 be the inverse 1. Minus 1 be the inverse of minus 1. I be the inverse of minus I. And minus I be the inverse of I. Okay. Now these are all inverses according to this one. Therefore, 1 minus 1 I minus I are inverses of 1 is 1, minus 1 is minus 1. We are getting the values 1 is there, minus 1 into minus 1 is 1. I inverse is minus I inverse is I is there. That's it. Okay. Now in the same manner, finally, commutative property is also satisfied. We are taking the value minus 1 into I is minus I into minus 1 is minus I. Now both values are same. Now this element is A and this element is B. A into B equal to B into A. Now so that's why all the entries must be filled in the composition table. Now we have to prove that we must prove that G under multiplication to form a finite abelian group. Okay, that's right. Now this is the very simple. Now according to the composition table, we should not mention all the postulates. Simple line is there. All the entries must be filled in the composition table so that all the postulates must be verified through the composition table. Finally, commutative property is also satisfied. G under multiplication form a finite abelian group. Okay, because finite means those elements are fixed elements because total number of elements given in the group is 4. That's why order of the group is denoted by O of G or mod G. Mod G notated as modulus of G means cardinality of G, cardinality of the group. So therefore total number of elements is 4. O of G equal to 4 or mod G equal to 4 is there. In sometimes order of the group, it read as cardinality of the group. O of G equal to mod G equal to 4 is there. Okay, that's enough. Now this is the set 4 and 4 imaginary of 4 and 4th roots of unity form a finite abelian group. Please note down, students. Now this is the another problem. Prove that a cube root. Prove that a set cube roots of unity. Prove that the set cube roots of unity elements with respect to the multiplication to form a finite abelian group. To form a finite abelian group. This is also another problem. Okay. Now this is what is the meaning of cube roots of unity? Unity means 1 is there. Cube root means 1 power 1 by 3 or 3 root 1. 3 root 1 means 1 power 1 by 3. That value is being the complex number is denoted by omega. This is the omega, just like that the small w, small letter of w. That is the notion. Just this is the bold of this part. 1 power 1 by 3 equal to omega. That is the meaning of cube roots of unity. 1 by 3 converting into this side, that is omega cube equal to 1. 1 converting into this side, omega cube minus 1 equal to 0. Omega cube minus 1 equal to 0. Omega cube minus 1 means 1 cube. This is a cube minus b cube formula. What is the formula of a cube minus b cube? A minus b of a square plus ab plus b square. That is the formula of a cube minus b cube. According to this one, a value is omega, b value is 1. Those values substituting given in this formula. Now that is omega minus 1 of omega square plus omega into 1 is omega plus b square means 1 square is 1. Now omega minus 1 of omega square plus omega plus 1 equal to 0. Suppose omega minus 1 equal to 0, we are getting the values omega equal to 1. This is one of the rule. Now just to have to observe this one, omega square plus omega plus 1 equal to 0. Now this expression is quadratic expression. Now we are not getting the ordinary factors of this part. Now through the quadratic expression, we must find out the quadratic roots. Okay. Now this is the equation in terms of omega is there. Now here the omega equals to what is the quadratic expression? Roots of quadratic expression. Roots of an quadratic expression is minus b plus or minus root of b square minus 4ac by 2a. Okay. Now here a value is 1, b value is 1, c value is 1. This is ax square plus bx, x means omega, plus c equal to 1. So that value substituting omega equal to minus b means minus 1 plus or minus Root of b means b value is 1, a value is 1. Coefficient is a. Here the coefficient is b. Okay. This is of the form a x square plus b x means 1 into omega plus c means 1 minus b and minus 1 plus or minus root of b square and 1 minus 4 ac 4 into 1 into 1 4 by 2a 2 into 1. Okay. Okay. Therefore, minus 1 plus or minus root of minus 3 by 2. Minus 1 plus or minus root minus 3. Root minus 3 means root minus 1 into root 3. Root minus 1 means I root 3 by 2. This is minus 1 by 2 plus or minus I into root 3 by 2. We are getting the value. It is the another roots of omega. One is the plus and the second one is the minus. Okay, listen carefully. Now this example, this especially this problem. Now there are so many times there are so many times given in the final examination or in the objective type. So many competitive exams are also there. Therefore, minus 1 by 2 plus I root 3 by 2, that is the omega. And another one is minus value, minus I root 3 by 2. Minus 1 minus I root 3 by 2, that is the another value. Okay. Now, what is the cube roots of unity elements? 1. Second one is minus 1 by 2 plus I root 3 by 2. And another one is minus 1 by 2 minus I root 3 by 2. So here the identity element is 1 is there because multiplication as the composition, 1 beats multiplicative identity. Now this is the omega, minus 1 by 2 plus I root 3 by 2. And this is omega square, minus 1 by 2 minus I root 3 by 2. Okay. Finally, G under multiplication, to prove that, now this is the, given the set of all elements, cube roots of unity elements are 1, omega, this value is omega, and this value is omega square. Now strongly fixed here. Now keep in your mind, what is the value of omega in cube roots of unity? Minus 1 by 2 plus I root 3 by 2. What is the value of omega square in cube roots of unity? Minus 1 by 2 minus I root 3 by 2. Now here the multiplicative by this 1. What are the elements of cube roots of unity? Capital G equal to set of here the one root is there. Omega value is also 1 is there. Now it begins with the 1. This value is omega and this value is omega square. Okay, here multiplicative by is there. Multiplicative inverse is always 1 is always inverse is 1. Omega inverse is omega square. Omega square inverse is omega. Directly because omega into omega square is omega cube, that value is 1. Omega square into omega equal to 1. That value, therefore, omega square inverse is omega and omega inverse is omega square. That is the inverses of 1 omega square by these elements given the set of cube roots of unity. Now, to prove that G under multiplication to form a finite element group, we shall show that, or we must show that G under multiplication to form a finite element group. Now, first of all, we must arrange the composition table. Multiplication as the composition 1 omega square. Now, those elements must be arranged as the columns and the rows. Okay. Now, here 1 is also multiplying with each and every element. We are getting the same elements given in this row. And the second one is omega is also another element. That element is also multiplying with each and every element given in the set. Now, just like that, elements are omega into 1 is omega, omega into omega is omega square, omega into omega square is omega cube. That value is 1. Now, omega square into 1 is omega square into omega equals to omega cube equal to 1. Now, that is omega square into omega square is omega power 4. That can also be written as omega cube into omega power 4. What is the value of omega power 4? That value is omega. How it can be that value? Now omega power 4 can also be written as omega cube into omega. Already we know that omega cube equal to 1. So that's why 1 into omega equal to omega is there. Therefore, omega power 4 equal to omega is there. Okay, just you have to observe. It is too clear. There is no doubt. Here, particularly each and every row, just you have observed here. There are no outside of the elements given in the row. Okay, 1 omega omega square, same elements given the set of cube roots of unity elements that irrespective of the row is there. Okay, now second one is there, omega omega square, and 1 is there. Okay. Now that's why omega square into 1 is omega square. Now there are same set of the elements irrespective of the row. Okay, that's why there are no outside of the elements. All the entries must be filled in the composition table. Now all the postulates must be verified. Now the postulates, G1 is closer. Number of times I must repeat it here. Don't forget this one. G1. This is G means group. The group of the first postulate, first law, first exam. Okay, first condition. What is that? G1 is closer exam. G2 is now the directly you should not mention the group is there. G means group is denoted by capital G. Ring is denoted by capital R. Therefore, ring of the first law, closer law, the R2, associative, R3. Suppose the ring is there. R3, existence of identity. R4, existence of inverse. R5, commutative. R6, distributive. Okay, now that's enough. Now here these 4 postulates must be verified in the composition table. That's why the given data must be satisfied and to form a finite invariant group, because A circle be equal to A into B equal to B into A. There is a commutative property. When the commutative property must be satisfied with respect to the multiplication as the composition according to the group of the elements. So that's why G under multiplication means here group of the elements means cube roots of unity with respect to the multiplication to form a group, and commutative when the commutative property is satisfied, that is called an invariant group. That's enough, students. Now these examples are two very important. Now once I have to repeat this one here, the G3 means identity element is 1, and G4 the inverses of 1 omega omega square are, so just you have to see here, 1 be the multiplicative by t. Here the inverses of given the cube roots of unity elements, 1 inverse is 1. Omega, when omega we are getting the value is 1, multiplying with the omega square. Therefore, the inverse of omega is omega square. The inverse of omega square is omega, because omega square here the omega value is 1 is there. Omega is also multiplying with omega square. We are getting the value is 1. So omega inverse is omega square. Omega square inverse is omega. Therefore, finally, 1 inverse is 1. Omega inverse is omega square. Omega square inverse is omega. That's it. Now, final commutative property is also satisfied. A cube roots of unity with respect to the multiplication as the composition to form a finite invariant group. Here, the group of R3 is mod G equal to, there are 3, number of elements is 3. Therefore, mod G or R O of G equal to 3. Okay, that's enough. Now, these are all very well-defined examples. There are so good examples to formation of a group or an abelian group. Okay, that's enough. Now, this is also one of the problems. These problems are just I have to explain in your textbook. There is no doubt. There are so many problems for formation of the group and finite invariant group is there. Now, this is also one of the example. Given the set capital G equal to, please note down, any set capital G equal to set of, students, please note down. Are you clear? Hello? Anybody explain here? Please respond. Is it okay? Hello? Okay. Please note down. In any set capital G equal to set of A, prove that. Please note down the question. Prove that any set capital G equal to A plus B root 2 such that A comma B belongs Q. Class lo unnarante ayundi chestam. Hello? Prove that the set capital G equal to set of A plus B root 2 such that A comma B belongs to Q. Set it is closed to form an abelian group with respect to addition as the composition. Respect to addition as the composition. Respect to addition as the composition. Once I have to repeat this question. Prove that any set capital G equal to A plus B root 2 such that A and B both are rational numbers to form an abelian group with respect to addition as the composition or ORR operation. Okay. Now, first of all, we have to observe here. Given the set is capital G equal to A plus B root 2. That is A comma B belongs Q is there. Now, how to the given data capital G equal to A plus B root 2 such that A comma B belongs to Q. Suppose here A and B both are rational numbers. Suppose A1, B1, A2, B2, A3, B3. There are so many elements are rational numbers mentioned here. Okay. Now, according to this one, A1 plus B1 root 2, that element is X. A2 plus B2 root 2, that element is Y. A3 plus B3 root 2, that element is Z. The same manner, identity element is additive identity. Here we must observe here the composition is what is the composition? Addition as the composition, particularly additive identity is 0. When we are according to the defined part, how to define the identity element? A must be 0, B must be 0. Therefore, 0 plus 0 root 2 means identity, additive identity. Okay, that's it. Therefore, first of all, we are taking in any two elements. Here A1, B1, A2, B2, A3, B3 belongs to Q. To prove that G under multiplication form a finite form an abelian group with respect to addition. Okay. Now, first one, G1 closer exam means let A comma B belongs Q. A1, B1, A2, B2. These are all rational numbers. Put X equal, let X equal to A1 plus B1 root 2, Y equal to A2 plus B2 root 2. Therefore, X plus Y equal to X element, X is X value substituting, Y value substituting. We are getting the value is A1 plus A2 plus root 2 of B1 plus B2. Now, this is the form of this value is A and this value is B, same element given in the set. Therefore, that is A plus B root 2. That is also belongs to G. Therefore, X plus Y belongs to G means G under addition must be closed. G under addition is closed. Second one, G2, associative law. AB or any two AB being the rational numbers and A, B, C are three rational numbers. X, Y, Z being the elements of capital G. X equals to A1 plus B1 root 2, Y equal to A2 plus B2 root 2, Z equals to A3 plus B3 root 2. What is the associative law? X plus of Y plus Z equal to, this is X plus of Y plus Z. Now this is A1 plus B1 root 2 plus of A2 plus A3 plus root 2 of B2 plus B3. Now that can also be written as A1 plus A2 plus root 2 of B1 plus B2 plus A3 plus B3 root 2. A1 plus A2 plus root 2 of B1 plus B2. That value is X plus Y plus A3 plus B3 root 2 means that is Z. Therefore, X plus of Y plus Z equal to X plus Y of plus Z. Therefore, associative law holds good. Associative law holds good. Third one, existence of identity. What is the existence of identity? X belongs to G, E belongs to G. Here the identity element is given in the group. Which is the identity element? Additive identity is 0. That's why the given element must be the form of 0 element. A must be 0, B must be 0. Therefore, 0 plus 0 root 2 is also belongs to G. What is the identity element? X plus E equal to E plus X equal to X. Here X means A plus P root 2 plus E means 0 plus 0 2 equal to X. X means A plus B root 2. Okay. Therefore, 0 plus 0 root 2, which element is also taken, repeated as the same element. Therefore, 0 must be adding with X. Therefore, we are getting the value is X is there. That's why 0 plus 0 root 2 is the additive identity. Next, existence of inverse. Here, X being the non-zero element is there. X plus of minus X equal to X value is A plus B root 2 plus minus X. So when which is the element? A must be the 0 means A plus minus A is 0. B root 2 minus B root 2 is also 0 root 2. B root 2 minus B root 2, that is also 0 root 2. So therefore the root of the inverse of A plus B root 2 is minus A minus B root 2. That is the additive inverse of A plus B root 2. The additive inverse of X is minus X, because additive inverse is subtraction. Therefore, we are getting the value is 0. X is also subtracting, X is adding with minus X. We are getting the value is 0. Now, in the same manner, X means A plus B root 2 plus minus X means minus A. Those elements are that is the inverse applying is there. Minus A minus B root 2. So, A minus A 0 is there. B minus B is the 0 root 2 is there. Where the value is the identity element is also repeated here. Therefore, minus X be additive inverse of X. X be the additive inverse is minus X. Now, this is the G5. That is the commutative. Now, these four properties are satisfied. G under addition form a group. Now, G5 is the commutative property. Commutative means any two elements are just you have to take in any two elements. Here A and B being the rational numbers. Any two elements are X and Y is there given in the set. Therefore, X plus Y equal to A1 plus B1 root 2 plus A2 plus B2 root 2. That is A1 plus A2 plus B1 plus B2 root 2. Therefore, A1 plus A2 is from the commutative A2 plus A1 with respect to addition. B1 plus B2 with respect to the addition of commutative is B2 plus B1. That's why A2 plus B2 root 2 plus A1 plus B1 root 2. This value is Y, this value is X. Finally, we are getting the value is X plus Y equal to Y plus X. Therefore, G under addition must be satisfied the commutative property. Therefore, finally, G under addition form an abelian group. Now, that's enough. These examples are very, very, very important in the final examination. Therefore, maximum there are so many problems in your textbook. Just we must practice. We will practice. There are so many examples according to these examples. Okay. Now that's enough. Tomorrow. Okay. Just to also please write. Now already I have explained what is the order of the group. Order of the group means suppose G under multiplication be a group or G under addition be a group, whatever it is. With respect to the composition, the number of elements given in the group is called order of the group. The number of elements given in the group is called order of the group, that is denoted by order of G over R mod G. Number of elements means whose the elements are finite. That is called a finite group. Otherwise, it is an infinite group. Okay, that is the finite and infinite group. Okay. Now, here the examples: capital G equal to 1 minus 1, I minus I. What is the cardinality of the group? This is the read as cardinality. Mod G means cardinality of the group or order of the group. The number of elements is 4. That's why group of the order is 4. This is the imaginary of 4 groups of unity. Suppose cube roots of unity means 1 omega square. Cardinality of the group means mod G, or order of the group means O of G. That is total number of elements is or 3 is there. That is the 3. Suppose there are 6 elements given in the group. Order of the group is 6. Cardinality of the group are also 6. There are both are same. Just you have to understand purpose. Some others referred as mod G. Some others referred as taken O of G is there. Okay. Now, is it finite or infinite? Set of 1, 2, 3, so on. This group is it finite or infinite? There are so many elements. So that's why it is an infinite group. Set of all integers. Is it finite or infinite? That is also infinite group. Okay. Okay. Now this is the concept. Next class, we will discuss the order of an element of a group. Okay, order of an element of a group. Entire the concept, just you have to see and refer in your textbook. There are so many examples, maximum important examples are also explained here. Now, according to the subject, I must explain here, especially through the subject point of view. Without subject point of view, there are so many theorems. How to by heart those theorems? Okay, first of all, we must understood the subject concept, and according to that, we have to whole practice. There are so many theorems are there. Okay, there is no problem. Next class we will discuss the order of an element of a group and some other theorems. Now, suppose next session, Lagrange theorem and subgroup necessary and sufficient of necessary and sufficient condition of a group to be a subgroup. Okay, there are subgroup necessary and sufficient conditions. There are two important theorems, and according to the Coset's theorems and intersection of the subgroups, union of the subgroups, Lagrange theorem for finite groups, Cayley theorem, entire these are all important theorems in especially and further session. And in the last but not least here, now that is the fundamental theorem of homomorphism in group theory especially. Now that is also one of the important theorem. And also Cayley theorem is also one of the important theorem. These theorems are very particular theorems in the final examinations. Okay, there is no doubt. And just you have to in this evening, especially once again, just I have posted some important concepts, some important theorems in WhatsApp group. Please check and verify in our WhatsApp group is there. Okay, now one PDF is also will be sent. Okay, there is no doubt. Now, just any doubt we have to discuss through WhatsApp. Yeah, once again, yeah, thank you. All the best. Any doubts? Just you have to post it in the WhatsApp session. Okay, thank you one and all. Wish you all the best. Wish you good luck. Any doubts? Hello? Any doubt is there? Students? Any doubts? Okay, thank you. Thank you one and all. Janaki or Dipti, whatever it is. Students, any doubts? Okay, wish you all the best and wish you good luck. Harsha, Janaki, Mamta. Students, please respond. Okay, thank you. Thank you one and all. Wish you all the best. We will meet again next session. Maybe now the date is
9th.
9th. Okay. On 9th, we will meet again. There are so many theorems are also explained. There are important theorems in final examination. Just this evening already I will send through WhatsApp is there one PDF. Okay.
Sir, on 9th we have practical exam, sir.
Practical exam. But already is also class is there. Already dates are also mentioned 9th, 10th, 11th, 12th. These 4 classes next session. Okay. No problem. Just you have to verify through YouTube. Okay.
Okay, sir.
Okay. Because this is the continuing concept. Because there is no jump here. Wish you all the best.
Thank you, sir.